In this video, we are going to talk about reducing expressions. So reducing an expression is when we take a rational function, right, that has algebra in the numerator and the denominator, and we look to see if we can find a way to reduce that by dividing out anything that they have in common on the top and the bottom. Now, before I go ahead and do that with algebra, we're going to take a look at how do I just reduce a regular fraction. So the fraction 6/10 can be reduced by dividing the top and bottom by what they have in common. So 6 and 10 both divide by the number 2. So I could rewrite this as 3 times 2, 6 is 3 times 2, and 5 times 2, right? 10 is 5 times 2. And I could say that this is the same as taking the fraction 3/5 and multiplying by the fraction 2 over 2. Now 2 divided by 2 is just 1. And anything times 1 just equals itself. So this would equal 3/5. So I could divide the top and the bottom both by 2 in order to reduce and get 3/5. Okay, so we're going to try the same thing, but this time with algebra. So it says reduce each of the following expressions, and I have x cubed plus 3x squared plus 4x plus 12 divided by x to the 4 minus 16. Now, right now, as it stands, I have no idea what would divide into the top and the bottom that might be the same. In order to figure that out, I need to figure out what multiplies to give me that top expression, what multiplies to give me that bottom expression. And the way we do that is by factoring. So I'm going to take the numerator and the denominator off to the side. I'm going to factor them, and then I will put them back in, and we will try to see what they have in common. I'm going to start with the x cubed plus 3x squared plus 4x plus 12. Now, this has 4 terms. So if I think about 4 terms, first option is a common factor. I don't see a number that divides into all of those, and I don't see that they all have an x, so it does not have a common factor. Our second option is that we can try to group in pairs. So I'm going to group together the first 2 and then the last 2 and see what it is they have in common. So the first 2 both have an x. Lowest exponent is a 2. So I'm going to say they have an x squared in common. And then x cubed divided by x squared leaves me with 1x. And then 3x squared divided by 3x leaves me with, just divided by x, leaves me with a 3. So I end up with x squared times x plus 3. I always take the sign that is in between the 2 groups, and then I look to see what goes into 4x and 12. They both divide by 2, but they also both divide by 4, so I want to go with the biggest number. So I'm going to say they have a common factor of 4. 4x divided by 4 is just x. 12 divided by 4 is 3. I do notice that these have the same bracket, which means I can continue. If they didn't have the same bracket, I would erase and then I would try factor theorem. But they do, so I'm going to say this is x plus 3 and then times x squared plus 4. Now, I do always like to check and see whether we can factor any further. The x plus 3 does not have an exponent, and they don't have a common factor, so that is not going to factor any further. The x squared plus 4 does have an exponent, so it doesn't have a common factor. It could be a difference of squares. A difference of squares is 2 terms, I have 2 terms, being subtracted. Unfortunately, this is being added, so it makes it a sum of squares, and sums of squares do not factor. So unfortunately, that is as far as I can go. So I'm going to replace my numerator with x plus 3 times x squared plus 4. And then for my denominator, I'm going to take that off to the side as well. So I have x to the 4 take away 16. This has 2 terms. They do not have a common factor. They are two terms that are being subtracted, and they are perfect squares. 16 is 4 squared, and x to the 4 has an even exponent, so that does count as a square. So what I'm going to do is use my difference of squares shortcut. We're going to square root the x to the 4. That's going to give me x squared. I'm going to square root the 16, which is 4. Now we're going to have the same bracket twice, but one is plus and one is minus. All right, from here I am going to see if I can factor that any further. The x squared plus 4 was the same as this part, so I know that isn't going to factor any further because it's a sum of squares, not a difference. But x squared minus 4 has two terms. They are being subtracted, and they are perfect squares. So I can use the difference of squares one more time. The square root of x squared is x. The square root of 4 is 2. I get two brackets that look very similar, but one is plus and one is minus. Oh, that's a little hard to see. Okay, so I'm going to take this and then pop that into my denominator. So I have x squared plus 4, x plus 2, x minus 2. All right, now that it is factored, what I want to do is look and see what they have in common on the top and the bottom. So what is something that I could divide both the top and the bottom by to reduce? So I notice that in the numerator and the denominator, I both have x squareds plus 4s. So since this is our first example, I'm going to show an extra step that I don't always show, but that I am going to put in because it is an example in our notes. I'm going to split this up and say that the numerator is x plus 3 and then times, and then x squared plus 4. And then in the denominator, I'm going to say this is the same as x plus 2, x minus 2. And then times x squared plus 4. So all I've done is I've just written this in a slightly different way. I split up the parts that will reduce with the parts that do not reduce. X squared plus 4 divided by x squared plus 4 is just 1. So this is really x plus 3 times x plus 2, x minus 2, and then times 1. And anything times 1 is just itself. So this is going to end up just being x plus 3 over x plus 2, x minus 2. And that would be my final reduced answer. Now it didn't ask for restrictions. We could put them in if you really wanted to. Things that could not go in our denominator would be -2, +2, and then if I set this equal to 0, I don't actually get an answer that works out. So it's really just +2 and -2 if you wanted to do the restrictions. Okay, well, I will see you in the next video to do the next example.